LED tubes are designed so they can easily replace fluorescent tubes that are inside overhead commercial light fixtures. Unlike traditional incandescent and fluorescent lighting, a light-emitting diode produces light through a microchip. It lasts twice as long and uses half the electricity. These LED tubes come in a selection of lengths. They're designed to be a modern, energy-saving alternative to fluorescent tube light fixtures. The manufacturing process begins with the printed circuit board. Printed means the board has a network of conductive copper lines and rectangular pads. It's designed to electrically link components. A technician places the circuit board on a track, which ferries it to the first computer-guided machine on the line. The machine covers the board with a metal stencil. The stencil has openings matching the locations where the electronic components will be mounted to the board. The machine spreads a layer of lead-free tin alloy solder over the stencil. This applies solder to the board only where the components go. The next computer-guided machine on the line mounts the first of those components, the light-emitting diodes or LEDs. They're composed of a microchip coated with a chemical phosphor and come in different sizes, colors, and light outputs. The factory programs the machine's chip shooter to pick the required LEDs off supply reels and place them on the solder-coated locations on the circuit board. The chip shooter works at an astonishing speed, placing up to 40,000 LEDs per hour. A camera trained on the board verifies that every LED's position is dead on. The circuit board moves to a third computer-guided machine for the next electronic component, the terminals. They receive the electric current to power the LED light tube. The machine picks up one terminal at a time and places it on the circuit board. The circuit board moves into the final machine on this line, a tunnel oven. The temperature inside peaks at about 460 degrees Fahrenheit. The heat melts the solder, fusing the components to the board. Solder is both adhesive and conductive. The bond connects the components to the board's copper electrical network. For the high light output tube they're making in this run, each board is comprised of 8 strips. Each strip has dual rows of LEDs. They snap them into 12-inch strips. The tube length they're making requires 4 strips. A technician slides 1 with the terminal and 3 without into an aluminum track. He gives them a visual inspection, then solders the strips to each other. Once soldered, the strips are electrically bridged, so the terminal on the first one can power all of them. The aluminum track is called the heat sink. It's critical to the tube's performance. It has deep fins on the bottom which dissipate heat, cooling the LEDs. This keeps the color of the light consistent and extends the tube's life. Once the technician connects the strips, he plugs power into the terminal to test the LEDs. Next, he inserts wires into the terminal and locks them in with a compression tool. The opposite ends of the wires connect to the power supply in the light fixture. The technician snaps a transparent polycarbonate lens into grooves on the side of the heatsink. He closes the tube by placing a cap on each end. He aligns each cap's pins with slots on the press. Then the press is activated, which forces the caps onto the tube, attaching them permanently. The end with the terminal has slots enabling the wires to protrude. The light tube is finished and ready to be shipped. To install this energy-efficient LED tube, simply click the pins on the end caps into receiving slots in the light fixture. Then connect the wires to the power supply and the fixture's wiring. Thanks to those cooling fins on the heatsink, This LED tube will last for 100,000 hours and has a guaranteed 10-year lifespan.